All right, I promised we'd be back in just a minute, and here we are. We've got one new face on the screen, and that is Milind Kulkarni, product manager over on EC2, talking to us today about a very, very exciting launch, and that is AWS Gateway Load Balancer. I only have so much breath, so I'll take a break for right now. But Milind, thank you for joining us.
Thanks for having me.
Awesome. So, we're talking about AWS Gateway Load Balancer. You're a product manager over on EC2 Networking. Why don't you tell us a little bit about, what you do here at AWS, and then we'll move into the launch today.
That's pretty much I do. I'm a product manager. My job is to listen to our customers, see what they want, what challenges do they have, and try to solve them and make their life better and easier.
Man, that's awesome. How do I get that job? No, I love getting to talk to folks just like you. I have a whole slew every other week. I get to talk to people that are doing great stuff. But awesome. I know that AWS Gateway Load Balancer made some splashes. There are a very select number of people who this solves a very salient pain point for, and we'll be able to dive into that in a little bit. But if it's possible, would you be able to sort of paint me a picture here of what the ideal customer is, or the story that they may be facing where application load balancer comes to save the day for them?
Yeah, I think it's a great question. So what I can do is I can start really at a high level. So this is essentially a new networking service, and I know sometimes we think of networking as a plumbing, that underneath layer that we may or may not understand. But imagine, and this is what we see the story repeat over time across many of our customer after customer. I'll just take an example of a representative enterprise customer. But the story is fairly common. Large enterprises or even small enterprises or government organizations, they have an established networks, structures, they have their existing infrastructure, they have components, networking components from various vendors. So they use devices such as routers and switches and specialized networking appliances, for example, like firewalls or intrusion detection or intrusion prevention systems, DDoS prevention, visibility tools, analytics tools, monitoring tools. I mean, you name it. All of these evolved in enterprise customers or even government customers. So they have a mix of all these equipment, and on top of that, they are used to these very specialized network functions or security functions or analytics functions that provide tremendous value and tremendous feature set. So customers love using these. They also have skill set that their people are trained in, their staff is trained in, using these appliances over a period of decade or so. Not only that, they also have operating processes that they've been using with existing on-prem infrastructure, maybe hybrid cloud infrastructure, and also in cloud infrastructure. And they're all trying to go to cloud world. And so not only they have skill set, training, operation processes, and existing large amount of investments there, how do you take that into cloud? So that's sorry, go ahead.
No, I'm see, I'm trying to put all the pieces and connect the dots in my head before you beat me to the punchline. We have all of these appliances, applications, on-prem infrastructure in many ways. Folks and customers have moved to the cloud, and there is just this burden or this friction that prevents them from being able to access the benefits they've come to know and love with the cloud. And is this where Gateway Load Balancer comes in? Is this going to help solve this problem?
Absolutely. So now that's exactly the punchline, and thanks for taking this there, which is now the gateway load balancer essentially allows you to keep your existing skill sets, keep your existing processes, keep your existing feature set of your favorite vendor, your favorite vendor relationships, and you can take all of that and just leverage in cloud. That in a nutshell is the gateway load balancer, and then obviously the technical details, but I think that's the prime value.
Milind, there's a really salient point I want to make sure I heard right in the narrative you just told us. You talked about a lot of customers making the transition from kind of on-premise to hybrid architecture to kind of more all in on the cloud. And a lot of these applications that you're talking about, they were kind of plug and play style of applications. I mean, not exactly like you said, some of these applications require really specialized training to use. But in a lot of these cases, you would have an application that was basically a rack or a chassis that you mounted in, you added to your network, right? And then that would fundamentally change the way that traffic was routed on your network, or it would do something to detect intruders, prevent DDoS, all those kinds of things that you mentioned. But one thing that stands out to me is, while that may be one of the ways that customers are used to operating, a decade ago, or you can't exactly, when you start building out your infrastructure in AWS, you can't exactly go to an AWS data center and plug in that same application, right? We don't really let you do that. So it sounds like in the middle there, that transition entails another very subtle switch, which is to use the virtualized version of the on-prem networking application as opposed to the physical version. Can you talk a little bit about that?
Yeah, absolutely. Yeah, and I think one salient point I'll add before that, even though we say networking appliance, the gateway load balancer really is quite broadly applicable. I mean, we use the example of a networking appliance, but it can really be, the gateway load balancer can work with networking appliance, security appliances, analytics appliances, telecom appliances, your IoT appliances, etc. Right? So it is all possible there. But coming back to the question you're asking, these were hardware appliances in the past. They evolved on a specialized function, and to bring them in the cloud, uh, we the industry essentially made them into virtual appliances, essentially software versions of those physical appliances that you can take with you in the cloud. And so since many of these appliances evolved from hardware base, the thought process, the design decisions that were made for hardware are different for versus when you make the design decisions when you run these in cloud, because the premise of on-prem data center based infrastructure is different than when you run in cloud. In cloud, you do horizontal scale elasticity, pay as you go, on demand, whereas in the older world, we typically do over provisioning, over engineering, things of that nature. So the design thought process is different.
Yeah, and one thing that I wanted to call out was that a lot of these, when you talk about the virtualization of some of these hardware appliances, the vendors of those physical appliances are our partners now, right?
Absolutely.
They form an incredibly valuable part of the partner ecosystem and the AWS marketplace, which is part of what makes AWS so powerful. The fact that you have highly supported, battle-tested implementations, virtualized versions of the software. This is not just some kind of repackaging. This is stuff that customers have been running for a long time. And the thing is, like, I think there's this virtualization software, in the case of some vendors, has been around for a long time. And even in their on-prem offerings, they do offer the ability to take either to deploy either the hardware-based version or the software-based version, right? And it's just that I think hopefully one topic that we will dive deeper into is, what are the different scaling characteristics of those two kinds of solutions, and how does the network load balancer address that?
Yeah, good
Sorry,
question.
gateway load balancer.
Yeah, and it's incredible. I think the customers also realize, and I come from one of those vendors in the past, is there's tremendous value in the software that our partners write. They have decades worth of experience. They have deep domain expertise in that area. So the feature set is extremely valuable. So customers now can leverage that skill set as is using gateway load balancer. The challenges that typically tend to be that virtual appliances face is around the scalability aspect of it. How can you scale elastically as on demand? So that typically tends to be challenge number one. The second challenge that customers will typically tell us is, how do I ensure reliability? If I have to deploy multiple appliances, how do I make sure I have resilient architecture that if one of them doesn't work well, the other one takes over, and how does that work? So that's the second challenge that gateway load balancer solves. The third challenge gateway load balancer effectively solves is essentially going around complexity. When you insert or when you use these appliances in cloud architectures today, the insertion is slightly complex. Sometimes it can be slightly complex to a lot more complex depending on how you do it. And one of the other challenge we see is to avoid those problems, customer tend to replicate those at different places, and then the management becomes really difficult. So all of these four challenges is what gateway load balancer is designed to solve.
Wonderful. I mean, to each of these points, when I'm thinking about sort of where they tie into, say, like my application stack, we have, it's a load balancer, but it's also a gateway at the same time. I'm trying to piece together the puzzle here, like thinking something like the OSI networking stack, right? This feels like it's on the network traffic routing side, which I think is layer 3. But then there's layer 4 that has like transport capabilities, right? The TCP, UDP, other transport protocols, and maybe it makes perfect sense to sort of bundle these together in a way to deliver those 4 or 5 pieces of value to these third-party applications that you described before.
Absolutely, so gateway load balancer, as the name indicates, and it's a gateway and a load balancer together. And what do I mean by gateway? Gateway is essentially any entry and exit point into your network. So it behaves like a layer 3 gateway, and layer 3 is an OSI layer construct. Essentially, it's a transport layer mechanism, how the devices exchange information. So it's a layer 3 gateway that any source and destination can just send traffic to. So that's the gateway characteristics. And then it also has the load balancer characteristics, where you now, when it sees the traffic, when gateway load balancer sees the traffic, it essentially behaves like a load balancer. Therefore, it gives you automatic scaling of appliances, stickiness of flows or stickiness of traffic to the same appliance. Number 3, it provides health checks to the appliances. So if any one of the appliances is down, the gateway load balancer can start rerouting the traffic through a healthy instance. And oh, by the way, the one interesting thing, the punchline there is, it does that in a transparent way. So when gateway load balancer is receiving the traffic, it sends it with an encapsulation to the appliance. So the appliance effectively sees the entire traffic as is. There are no modifications to the packet. I know I don't want to go necessarily into the deep level details, but that is not changed at all. So the appliance is able to process, is number one, see the traffic and process the traffic exactly as if it was sitting in line. No modification on the software side, on the source and the destination, is necessary.
Yeah, that's a very good way to put it. I can see that it would be very difficult to achieve what these appliances try to do without the ability to plug in at these lower levels of the OSI networking stack, right? Because if you think about it, let's say you run, let's just, for the argument's sake, a spam filter, something that's trying to make sure that you don't get malicious emails coming into your network. Mm-hmm. Imagine if you run it in an EC2 instance. Well, the only way the spam filter can actually work is if then you make that thing this proxy for SMTP traffic, right? But what you're saying is that we don't have to do that. We don't have to do it at the application layer. We can do it on a much lower layer, and that makes it consequently more architecturally sound, more scalable, and more efficient, right? More performant, if I understand you correctly.
Absolutely. Yeah. So the benefits are I think you summarized it pretty well. It provides scale, it provides reliability. You can insert services transparently at a native level to Amazon. So a third-party provider or a partner or even a do-it-yourself user can write their application in a native way that can scale in a cloud native way. It can have reliability in a cloud native way, can be inserted in the traffic in transparent way, and can be offered as a service. We have a concept, we have a construct. I think in the previous section you talked about the endpoint, the private link concept, and gateway load balancer can also be exposed in another VPC and another completely different user account using the private link. So now, all of a sudden, your appliances can reside in one VPC, and you can offer it as a SaaS in a completely different account. So you can literally, in a short amount of time, if you're a partner or if you're a user, you became a SaaS provider of your appliance. And then effectively what that means is you focus on your core expertise. Appliance vendors, our partners, our customers have core expertise in their domain knowledge. You just focus on that. Let Amazon worry about scale, reliability, service delivery, flow pinning, etc. That allows you to allow your existing processes, existing skill set, existing intellectual property, all of that you can just leverage as is.
I love sentences that begin with "Let Amazon worry about X."
It's you know, that's actually, like, I know, Rob, you put it like very, very plainly right there. But you know, like, if I'm thinking about the things that I don't want to worry about, you're like, if I'm an end consumer, I want a solution or an appliance that solves my problem. And I just, like, I would argue that as a consumer, the appliance scaling or having the right throughput is part of the equation of whether it solves my problem or not. And so, you know, again, letting a particular vendor or one of the partners or someone who deeply understands a problem like intrusion detection or spam filtering work on their application and not have every single person need to worry about the, you know, internal scalability of managing their own fully fledged service, that becomes a significantly easier, you know, you can focus on the thing that matters most to your customer. Insofar as something like now, gateway load balancer exists. So, you know, like, I'm trying to pair some of these challenges to discrete sort of on-prem environments, right? So let's talk about scaling, elasticity. You know, we're spoiled for choice, I think, in AWS and cloud world, where you have the ability to on demand scale up and down. You have what can often be very smaller discrete units that you can scale up and down by, so they're not large jumps. Contrast that to on-prem, right? Especially with these typical on-rack appliances, you may have to buy a second a second copy of this physical device. That may not be a small investment. They may be very large, right? Then we go into over provisioning, right? That's just simply not cost effective. We talk about reliability, right? Having failover in a way implies that you already have multiple copies of an application or a device running, which could be cost prohibitive in, on-prem, management and ops prohibitive. But in cloud, with something like gateway load balancer, that becomes significantly easier too.
Absolutely.
And then there's the whole spaghetti monster of management, right? As you have, a mature application, you've got lots of moving parts, and management is a incremental cost that comes along with all of that too. And so, being able to, again, have that tied into a managed service that, you said there's full transparency into the traffic and how it's moving, right? And the application can still have its own monitoring systems in certain ways if it wants to, but can tie into gateway load balancer to be able to achieve that.
Right. Yep.
Awesome.
Yeah, and one thing I wanted to revisit real quick, that you mentioned really early on, is just the amount of institutional knowledge that this pattern, so to speak, helps maintain. Right. I mean, these companies that we're talking about, often when we talk about on-prem and migration to the cloud and all these things, the devil's really in the details. This is a different story for every single industry vertical. Every single company has their own nuances that you need to work through. If you see these migrations happen up front, you'll know that no two are alike. And in a lot of cases, what makes the migration successful is that the customer feels a sense of confidence that their workloads are not going to be disrupted. And a lot of that times that comes from their networking teams and their ops teams, which this is often where some of these appliance engineers and appliance operators sit, right? You have somebody who, let's say, for sake of argument, is the networking person who has helped the company fend off multiple DDoS attacks, has helped the company overcome a number of scaling challenges when there are unexpected spikes that are totally legitimate. And they did this because they were able to, they were masters at operating, let's say F5 big IP, right? As a business, imagine that. Imagine you're in the driver's seat. Imagine you're the CTO or the CEO or the CIO, and you're about to make this huge leap into the unknown of, you know what on-prem is like, you know how to overcome those challenges, and you know that these challenges are a threat to your business. How do you address these same problems once you're operating in a VPC inside EC2 and you're relying on the Amazon global network, right? The answer is not just a bunch of technical, like, hey, here's how this works, here's this throughput, here's this thing, here's a spec sheet. It's not just that. It's, can you talk to your network appliance engineer and say, do you feel good about this? Can we move forward with this, right? And so the idea that you can kind of bring along that expertise and all those lessons learned is tremendous. That, I think, is one of the common things about these migrations, is that there's the human factor. These migrations are deeply, deeply just human factor problems.
Yeah. So true. So true. So I think maybe then there are two distinct set of customers we typically see with this, right? One, we talked about, there is a benefits to gateway load balancer to our end customers, and there is benefits of gateway load balance to our partners, right? And both of these have to do with the human factors, as you mentioned, right? And the existing investments. So it's quite important. So I think, if I may, I can summarize those really quickly again. For our end customers who are the government orgs or even enterprise customers, small, large, medium, they typically see 6 benefits out of this. Number 1 is they can use their existing third-party appliance skill set. Number 2 is they can use their existing tools and practices that they've built around these appliances. Number 3 is it simplifies the appliance deployment because it allows you to insert them in a simple manner. And number 4, now you can get scalability, elastic scale to the appliances. Number 5 is gateway load balancer allows you to improve the availability of appliances. And the last is you can share appliances across VPCs, across administrative boundaries, across accounts. So if you are a CISO team, if you're a security team, you can control your budget. You can take care of your appliances in one VPC, and you can simply offer that in other VPC as a service to your internal customers, your internal consumers, different departments, production workload, etc. So those are 6 benefits for customers. For our partners who have been writing appliances, who have been in the business of writing these specialized appliances for decades, what they get is they get essentially 4 or 5 benefits. Number 1 they get cloud native elastic scale. Number 2, they get cloud native availability because of the infrastructure that we offer at AWS. Number 3, they get to simplify their deployment architecture that also reduces their time to deploy and time to value for their end customers. Number 4, because as we talked earlier, is because now Amazon handles the problems of scale, availability, simplicity, etc. The vendors, the appliance partners can focus on their core competence and innovate faster. They can push the envelopes of technology. And the last, but not the least, is they can offer their software or the virtual appliances as a managed service that they can, not only they can sell, but their partner, what we call it as managed service providers, can also sell, maybe white label, maybe sell it as their own brand.
Awesome. I mean, this is a lot to unpack. I have not worked personally with some of these on-prem appliances, but even in the virtualized scenario, I think seeing it may make it more clear. Milind, absolutely. I believe you have a special friend that's probably going to join us that can potentially show us a little bit more about it.
Absolutely. Would love to show you. Why just talk, right? Let's see it in action.
Wonderful. Well, we're going to be back in just a minute, 2 minutes, I promise, tops, and we will have a demo for Gateway Load Balancer. So stick around, everyone. We'll be right back. Okay, we're back. Definitely less than 2 minutes. I promise. I was counting. So to finish off this second session here, we have a demo of AWS Gateway Load Balancer. But first, we do have a fresh face. Samir, you want to tell everyone a little bit about what you do here?
Yeah, sure. I'm Samir. I'm a partner solutions architect at AWS. I focus on building new integrations and solutions for customers that work with some of the partners that you guys were chatting about who build some of these appliances that work on AWS today.
Perfect. Well, there's no better person to show us a demo of how to integrate Gateway Load Balancer than you. So we're grateful to have you. Why don't you tell us a little bit about what we're going to be able to see today?
Yeah, absolutely. And I did catch the part that today is Friday the 13th, so I hope the demo gods are happy with me. Um, what I'm going to walk through today is sort of how you typically get traffic delivered to the gateway load balancer and the appliances behind it, as well as why or how do you make those changes to make this happen. So I've set up this infrastructure where you have a gateway load balancer that's in a separate VPC or virtual private cloud. This is typically it can be in an environment that exists in the same AWS account, or this can be in a different AWS account. And this is where the use cases can differ, because this is maybe a use case where a partner is building a managed services and has the appliance along with the appliance VPCs in a separate VPC and account. And they're just enabling customers to drop these VPC endpoints that we're going to use to route traffic to this service that's running behind the gateway load balancer. Uh, the scenario here is I'm just going to have traffic hairpin out of these instances, simulating something like a security use case, whereby I'm forcing all traffic, whether that's inbound from the internet, in which case I'm pinging this instance here, which I consider an application instance, um, and making sure that it's inspected before it goes out. So right now, the way I have this set up is I have a gateway load balancer, and behind it are two appliances that I'm simulating, which are currently healthy, which means that I'm doing a bunch of health checks to ensure that these appliances are actually able to receive traffic. So that also removes some of that extraneous stuff that customers or partners had to build to enable high availability. And then on the setup side, I also have an appliance or an application instance that I'm going to use to hit from the internet. In this case, I've just built an HTTP server, but I'm also running a sort of ping that is continuously generating ICMP traffic to that particular instance. And to confirm that, I'm just doing a TCP dump, which is basically a packet dump that would give me information on where it is that I'm actually receiving this traffic. So you'll see the IP address is something here. And why this is important is we talked about how it enables a transparent method of inspection, which means as this comes into this instance, applications sometimes need to know the actual client IP, in which case this is super useful for them in the cases where they need to know based on the IP, they're doing geolocation or something like that. They can use this to sort of transparently inspect the traffic. So what's it doing right now? Right now, the setup is such that I have all of the traffic being routed through the internet gateway, in which case it's directly going to the internet unfiltered. And to enable this traffic to go through the gateway load balancer, all I need to do is modify those route tables to ensure both outgoing traffic and inbound traffic is sent through the endpoints that we just created. So I can go ahead and do that. The two things that I'll modify, one is the VPC route table or the subnet route table that's associated to where the actual application instance sits. So you hit your edit routes. And what we've done is we've enabled a new sort of target in the route table, which is now called the gateway load balancer endpoint. So customers can use the same EC2 route add API call or go to the console and use the console's target as gateway load balancer endpoint to start pointing traffic to that endpoint that's created. You hit save routes. Now you'll see that there's a little bit of a drop in traffic, and that's only because I've not fully enabled stuff yet. And that's the only reason I didn't do that is that I need to enable the ingress side. So as traffic's flowing out, I need to ensure that traffic coming back is also routed through the endpoint. This also ensures that for firewalls and appliances that need symmetry, we're enabling the use case where both ingress and egress traffic is sent to that same device. So point it back to the gateway load balancer. Oops, got my subnet wrong. And you should see traffic coming back up now. So it's as simple as enabling that. Now, if I go back to my actual application instance, you'll see that I still have the same set of information that I had previously, which is it's still exposing the client IP and it's still going through the gateway load balancer and through those appliances. Now, how do I know that? If I go to one of these app appliances and I'm doing a TCP dump there again, you'll see that I have traffic coming in and out of this particular appliance which sits behind it. So before you might have not had that traffic being inspected, but just changing a couple of routes once things are, the endpoints are set up, it's as simple as just flipping those two routes and you're starting to inspect all traffic that comes in and goes out of that VPC.
Awesome. I mean, this is, I think, just the realm of being able to bring this horizontal scalability and reliability to any arbitrary third-party application that you run on an EC2 instance, or that someone else that you through the partner network or through the marketplace are using. Like, the peace of mind that you can have as a customer that they can be using something like Gateway Load Balancer, or you can be using it to run your own custom appliances or third-party like custom applications, I think is an immense value proposition, right? Everyone loves scalability, they love reliability, they love all of the values that we heard talked about before. And in just a few minutes, we saw you able to set that up, and basically doesn't matter what third party application it would be, it could be really anything that lives on that EC2 instance, right?
Absolutely. So in this case, it was just a standard Amazon Linux 2 instance that I configured IP tables on to hairpin traffic back to the gateway load balancer. So you can pretty much start thinking about, creating any custom logic on top of that and build applications that can do multiple things, right? You can sort of have an application that, reads the traffic, can potentially identify all of the unencrypted traffic and display it on the screen for you. So there's multiple use cases that you can enable even if you write your own custom logic for this.
Awesome.
Samir, we have a question in Twitch chat. If AF5CL asks, this is awesome. Any chance we could route mirrored VPC traffic through this gateway?
Yeah, so this is an interesting use case, and I think we have partners that are doing something similar. But what it enables is because we are routing all traffic transparently to these set of devices that exist behind the load balancer, you can sort of tap from the instances themselves using VPC traffic mirroring, which customers have been using for a while now. So you can mirror the traffic from the appliances directly and have the visibility that you need from sort of a centralized point where all of the traffic from all of your VPCs are coming in for inspection.
Wonderful. Thank you. Well, this was we got the deep dive leading up to this, and then Samir just showed us this awesome demo. I don't see any other questions in particular in chat, but Samir, sort of any closing thoughts? I know there's some resources in chat where like for getting started or replicating this demo, there are some links to the CloudFormation template over there. But anything you'd recommend for customers that are looking to get started, get their feet wet with Gateway Load Balancer?
No, I think we have a good summary of how you can build this out in a couple of blogs that we've released over the couple of days. One, we talk about sort of the architectural patterns. I know a lot of customers have asked around how can I centralize this with AWS Transit Gateway. We will have, this does work with Transit Gateway as well, and that blog that I talked about, which introduces those architecture patterns, goes into some of it. And how you build this particular architecture out, we have another blog that talks about it, including code samples. So yeah, go through the blogs, get your hands on the GitHub repo that hosts these, and you can set this up in minutes again.
Awesome. Samir, it's been a real pleasure. You flew through a lot of concepts, but you did so in a really succinct and easy to understand way. So, anyone who this could potentially solve the problem for, I'd feel very confident if I were in their shoes to being able to go and try to start implementing Gateway Load Balancer to solve some of my problems. So thank you again.
Thank you.
Awesome. Well, that will conclude session number 2 of 4 on the day. That puts us about 50% of the way through, a little past 50%. We had the opening segment that we like to do. But without further ado, we will be right back. When we return, we will be joined by a member of the AWS Glue Data Brew team to walk us through this very exciting launch in the data cleaning space. So stick around, everyone. We will be right back.